Let's find one more very common power series, Maclaurin, centered at 0. We'll start by finding multiple derivatives. I think we can stop at about the fourth derivative on this one. Let's start by rewriting this function though. So that's going to give me 1 minus x to the negative 1. Let's find some derivatives. Let's go rather quickly. This is going to give me negative 1 minus x to the negative 2. Okay, I just said negative 1, but I didn't write it because negative 1 times chain rule, negative 1 would give me positive 1 again. All right, f double prime of x is going to give me negative 2, 1 minus x to the negative 3. Chain rule, negative 2 times negative 1 is going to give me positive 2. These are going to be positive in the front, just saying. F triple prime of x is negative 6, 1 minus x to the negative 4. Negative 6 times negative 1, positive 6. Let's do that. Looking ahead, that's why I didn't put the negative. Get tired of erasing these things. 24. 1 minus x to the negative 5. You know the deal with the signs. Okay, let's start writing a few things down. It's going to help us out as we evaluate. Actually, let's evaluate first. So let's go to what color? Green. That works. So we're going to evaluate each of these at 0. It's going to be pretty easy. So f of 0 is 1 over 1. Good. F prime of 0 is 1 times 1 minus 0, which is 1. 1 to the negative 2. 1 to any power, basically, is going to give me 1. So all these, where I plug in zeros, they're going to give me 1. So this is 1. F double prime of 0, with bad handwriting, is going to give me 2. F triple prime of 0 is going to give me 6. And F fourth prime of 0 is going to give me 24. Okay. Clearly you see a pattern with that, right? Do you? Huh? 1, 1, 2, 6, 24. What's the next one? I'm not telling. But it's 24 times 5, which is 120, which is 5 factorial. 0 factorial, 1 factorial, 2 factorial, 3 factorial, 4 factorial. Let's write some stuff down. All right. My Taylor polynomial t of x, it's from Texas, is, I like to write it when I have the time. It helps me remember the formula. So f of 0, x to the 0 over 0 factorial plus f prime of 0, f prime, don't make it look like a 1, make it look like an apostrophe, x to the 1 over 1 factorial plus f double prime of 0. This gets really old really fast. You can see where this is going. We'll stop at the third one. X to the third over 3 factorial plus forever. Okay, really exciting. We're going to plug in some numbers, and when we do, we get 1. Okay, with cosine and sine, we had some 0 terms. Not here. So 1. Awkward slanted 1, but 1 nonetheless. F prime of 0 times x, so 1, x. I should write a little neater. How about that? There we go. F double prime of 0, so 2x squared. 2x squared over 2. Okay, you can see where that one's going to go. And then the next one's going to be 6x cubed over 3 factorial. 3 factorial is 6. Okay, really, you can see where this is going. I'm going to go one more just because I'm having so much fun. But 24x to the 4th over 24. Okay, beautiful. Beautiful. 1 x to the 0 plus 1 x to the 1 plus 1 x to the 2. Let's quit putting the 1s. Let's not put any 1s ever. There we go. Plus 1x to the 3 plus, you get my point. What's the general term? Clearly no fraction. So plus, the general term would be x to some power. What power? If this was the 0th term, first term, second term, third term. So if I went old school on this, like I did on the previous 2 problems, and I was like, n equals 0 and the exponent is 0, n equals 1 and the exponent is 1, you know where this is going, right? So n. And it keeps going after that. So let's do it. Final answer in purple. 1 over 1 minus x equals, fun stuff, the sum from 0, come back, there we go, to infinity of x to the n. But, you saw this in the last video, this doesn't always work. Because there's an asymptote at 1, so it's not going to jump over that asymptote. It's centered at 0, it doesn't jump over the asymptote. There is a radius of convergence here. This only works for x values between, but not including, open interval, -1 to +1. This works for the interval from -1 to +1 only. Clearly, we couldn't even plug in a 1, and then -1, it just falls off on that end too. So it'll never converge on those. Good to know. You need to memorize that one.